The object must be downloadable via URL. Which storage option would you choose? The first option is Amazon S3. That sounds like a good option for us because when you store your object in S3, there is a URL that you can use to access that object. Second option is Glacier. Glacier is like for archiving system, so it's not the case. The C is Amazon Storage Gateway. Doesn't sound like an option for us. D is Amazon EBS, and we know EBS is the kind of virtual hard disk. So I would go with Amazon S3. I'm suspicious about this one. So let's see what's the answer. So right. So S3 is perfect storage option. So provide facility to us for assigning a URL to each object. And we know we can build actually a website, simple website with AWS. Second question, there is a requirement to host a database server for a minimum period of 1 year. So when we're talking about like database, then we need this instance to be available 24/7, dedicated for us. Which of the following would result is in the least cost? We're talking about least cost. Least cost usually go with spot instances, but because spot instances can be taken away from you anytime, then we drop this answer. Second one is on demand, but in this case, we are talking about database available for you 24/7. So I'll drop this one, and it's also not the most cost effective in this case. The C is no upfront cost reserved. Reserved is an option, but here no upfront. That doesn't go with the least cost. So D is a good answer because we can partial upfront cost, and it's a reserved instance for us. So D is the right answer. And because they said, for example, for on-demand is not the most cost-effective, efficient solution. Usually when you pay upfront and you sign the contract, that's when you get the most effective cost. During an organization information system audit, the administrator is requested to provide a dossier of security, compliance reports, and online service agreements between organization and AWS. Usually when you read this word compliance, you usually like directly think about AWS artifact. You just drop everything else. And this is right, as you can see. Question 14, a new department has recently joined the organization and the administrator needs to compose access permission for the group of users. Given that they have various rules and access needs, what is the best practice approach when granting access? Usually when we talked about granting access, it's preferable to go with the minimum minimum permission or minimum privilege. So let's see what are the answer. After gathering information on their access needs, the administrator should allow every user like this word, every user just like kind of like drop the answer. Like this is not the answer. No, I don't need to go and continue that reading this option. B, the administrator should grant all users. Wrong. All users, every user. Wrong. I don't need to finish reading. C, the administrator should grant all users the least privilege and add more privilege to only to those who needs it. That sounds like the answer. I give them the least privilege, and whoever needs more privilege, I will give them that. Show the answer. It is C. There is an external audit being carried out on your company. The IT auditor needs to have a log of who made the request, who did what. That goes to Cloud Trail all the time. without exploring anything. So it's like there are keywords, you know, in your head's like, oh, who did what? Then that's CloudTrail. Which of the following features can be used to preview changes to be made on AWS resources, which will be deployed using AWS CloudFormation template? And in this case, you need to educate yourself more, including me, about the CloudFormation here. So there is like the drift detection. Usually this happens outside of the cloud front. So this does not apply here. AWS CloudFormation change sets, that sounds like an answer. For the cloud stack sets like this one, like the cloud stack usually like give you like kind of a general overview. It does not dive deep into this each set. So let's see the answers here. And they say B is the answer. AWS Cloud Formation change set can be used to preview changes to AWS resources when a stack is executed. Resources. Okay. Option A is incorrect because drift detection is used to detect any changes made to resources outside of CloudFormation. Option C is incorrect as there are groups of stacks that are managed together. So it gives you a general overview. And option D is incorrect as these intersect functions are used for assigning values to properties in CloudFormation templates. Which of the following is the responsibility of a customer to ensure the availability and backup of the EBS volumes? We know EBS is like a virtual hard disk on the cloud. So what is the functionality? What we can do about saving? Like say I wanna to avoid any crash, I wanna save every week. I wanna take a copy of that and save it somewhere. So in case, you know, I wanna go back to a week before or a month before, I have to use that. Delete the data and create a new EBS volume, that's dump. Create EBS snapshots, that's the answer. Snapshot is the keyword. Attach a new volume, here we're not talking about scalability or anything. Create copies of EBS. Yes, we are creating copies of EBS, but using snapshot. So snapshot is what they say, EBS volumes cannot be copied. They can only be replicated using snapshots. So that's what I was talking about. When designing a highly available architecture, what is the difference between vertical scaling, scaling up, and horizontal scaling? Scaling up means like if you have an instance with like minimum resources. Scaling up means like I'm increasing these resources, like I'm increasing the CPU, I'm increasing the size of my hard disk. But scaling out means that I'm increasing the number of instances. So scaling up provides for high availability, while scaling out brings fault tolerance. That sounds right to me. B, scaling out is non-cost. This is like, we're not talking about cost here. This is wrong. Scaling up adds more resources for an instance. That sounds correct, actually. Scaling out add more instances. That's what we're talking about. Like horizontal means like adding more resources. Up meaning add more resources to an instance. So that sounds more correct than A. Scaling up provides for high, probably this part is throwing me off. This sounds right, but this part's throwing me off. Let's see what is the answer. It is C. So just see why A is incorrect. Scaling up does not provide high availability. That's why that part was throwing me off. Adding more resources to an instance is not often a best practice in architecture design. Cool. So the answer is scaling up, add more resources to an instance, scaling out, add more instances. Your company is planning to move to AWS Cloud. You need to give a permission, a presentation on the cost perspective when moving existing resources to the AWS Cloud. Considering Amazon AC2, which of the following is advantage from cost perspective? A, having the ability of automated backups. Definitely no, because we're talking about cost here. So B, the ability to choose low cost AMIs. That's not correct. The ability to only pay for what you use. That's totally the purpose, like the main purpose of going to AWS. I'm just gonna pay for what I'm using. Tag instances is just like for, kind of tracking or like grouping instances together. It's kind of organizing instances. So C is the right answer, as we said. Question 20. When designing a system, you use principle design for failure and nothing will fail. Which of the following service feature of AWS can assist in supporting this design principle? Okay. Availability zones. This sounds good to me because the more availability zones you have, the better, because if one availability zone fails, then there's one up. Regions sounds also correct. If the whole region failed, there's another region up. Elastic load balancer is a good answer, because imagine like the traffic coming to one instance is going to be overwhelmed and crash. Elastic load balancer, it will take the traffic and like kind of divide it between instances to keep the system up, so you kind of avoid the failure because all instances are healthy. One instance goes down, the load balancer knows that I'm going to now take the traffic and take it to another instance. Pay as you go pay as you go is not an answer here, because we are talking about we're not talking about cost, we are talking about failure and load balancing. So that's my answer. Show the answer. As we say, it is what we said. I'll stop right here, and then hopefully I can see you in another video. Thank you so much. I appreciate your support.